this example, I'm going to focus on the first few pages of 1 is a snail, 10 is a crab by counting up to 10 feet. On the front cover, you can ask how many feet does a snail have? How many feet does a crab have? How many feet do you have? And how many feet do we have altogether? The key mathematical concepts that are represented in this text are that numbers have a stable order, we need to use one-to-one correspondence, that is, that each foot can only be counted once. Cardinality, which means that the last foot we counted represents the total number of feet we have counted. And finally, that numbers can be made up of different combinations of feet. I suggest reviewing the text a few times. The first read-through can be done without interrupting the text. For the second read-through, practice counting the feet on each page before reading the text. If you are watching a YouTube video, you can pause the video to do this. To move beyond the text and to start analysing the information, students can focus on a particular number and do a card sorting activity, firstly up to 10. This version represents a retelling of the story and practicing counting skills. You'll notice when children are doing these activities with the text or in this format that they might count every foot. This builds fluency in counting from 1 to 10. Being able to count from any starting point is an important skill, so to build on counting every foot to make 3, you might start at 2 feet and count to 3, or to make 5, you start at 4 and add 1 snail to make 5. In this activity, students focus on the number 4 and use picture cards to create as many combinations of 4 feet as possible. In this example, students are asked to make combinations of 10 feet. In the row at the bottom, this response could be a result of asking, how can you make 10 using as many different cards as possible? As you can see, this is not the most efficient way for us to get to 10. By asking the question, what do you notice? Students can start to consider key ideas, such as the larger the number of feet, the fewer cards we need to add to 10. Other questions that you can ask are, can you show 10 feet using only the person cards? Can you make 10 feet using the dog cards? If not, why not, and how many more do we need? Can you draw 10 in different ways? Can you make 10 with objects that are available at home, such as toys or items from the pantry? These questions demonstrate to students that 10 as a number can have many variations. 10 can be 9 and 1, or 8 and 2, and so on. The benefit of these activities is that they can extend from counting numbers to representing numbers and finding patterns, such as all even numbers can be made by using the person card with 2 feet. This activity can be repeated with other numbers. Children can select a number and draw their own animals and use larger numbers as part of a mathematics investigation about how many different combinations of feet they can create. These images can be drawn, copied from online sources, or photographed by students to make their own books. Asking good questions can support students with saying and writing numerals to making broader generalizations about rules and patterns. Reading and rereading the text and doing the activities regularly allows students to practice and reinforce counting skills by 1, or counting by starting from any number and skip counting. The beauty of this book and associated tasks is that it also builds a student's number sense and number meaning. While I've focused on counting to 10, this book can also be used to develop understanding of numbers up to 100 and fluency with basic addition and skip counting skills.